Hi guys, welcome back to my channel. So in this video we are going to discuss the Leetcode problem, continuous subarray sum. So what is the problem statement? Given an integer array nums and an integer k, and we have to return if nums has a continuous subarray of size at least 2 whose elements sum up to a multiple of k. Otherwise we have to return false. And an integer x is a multiple of k if there exists an integer. Actually this is the definition of the multiple. So let's see. Friends, before moving forward, we must know what a prefix sum is. If you know about prefix sum, then it is good. But if you don't know, then don't worry. I will going to explain it in short what a prefix sum is. So prefix sum is nothing but basically a array, and you can assume like if you are at first index, then you will store the sum up to first index. If you are at second index, then you will store the sum up to second index, and that is 23 plus 2. And if you are at third index, you will store the sum up to third index, all the elements, the sum of all the elements up to third index, that is 23 plus 2 plus 4, that is 29. And if you are at fourth index, and you will store the sum up to fourth index, that is 29 plus 6. And at seventh, you at this index you can just add this 7 to this 35 and you will get 42. So this is the prefix sum, and k given in this problem, in this you can say in this test case k equals to 6 is given. So basically what I am trying to say that we have to find modulo k values of the sum of the subarrays. So how we can do this? For this I have designed the approach for you. What we have to do, we have to find prefix of I minus prefix of j modulo k. So first of all we need to understand what is this prefix of I minus prefix of j indicates. So this prefix of my suppose the I is this and j is this index. J is 0th index and I is 4th index. So prefix of I minus prefix of j, what does it mean? That is 35 minus 23. What the answer will be 12. And 12 modulo k, that is 12 modulo 6 will be 0. So we have to find these kind of indexes, and if we are able to find these kind of indexes, then we will return 0, return true, otherwise we will return false. So this is our main motive. So what we can do, I am just simplified this expression again. So we can take modulo to these elements different, and then we can move this element to RHS. And what we will get, prefix of I modulo k equals to prefix of j modulo k. So this is the base condition that we have to check. Guys, now our question is very straightforward. We just need to find these any these two I and j for which prefix of I modulo k and prefix of j modulo k will be equal. If we are able to find out any of these I and j, any combination of I and j, then we can simply return true, otherwise we have to return false. So what we have to find, prefix of I modulo k when it will be equals to prefix of j modulo k, where I and j must not be equal. So for these what we need, prefix of I with modulo k. So that's why what we have calculated here, for every prefix we took modulo with k and stored this instead of this. This will be easy for us to find this condition, to check this condition. Now in this case both of these may be the case, because we find 5 here, 5 here, that is we find these two are equal. Prefix of 0 and prefix of 2, both of these are equal. So this may be the case where we will get our solution true, and this also may be the case where prefix of 1 and prefix of 3, we can say yes, prefix of 3 is equal. So this will be also the case, so we may return true here. Now we can understand better here what we are seeing, prefix of 4 minus prefix of 2. If we consider this a 1 based indexing, then prefix of 4 is this one and prefix of 2 is this one. If we subtract both of these, we will get a 0, and then we will return 0. If no such prefix of I and prefix of j exist, then we will return simply false. So this is the main motive behind this question. Guys, now I want you to try the question and move forward. If you are stuck at any point, then you can see the C++ code, and I will post that code in my first comment section, and I will pin that comment. So from there you can see the code for this question now. But before seeing the code, I want you to try first and try to implement this code of your own. If you are able to do this, you do that, and that's good. But if you are not able to do that, that also good. You should keep trying, and you can check out my code in my first comment. So Bye bye guys, see you in the next video.